Part 1, we're going to calculate the rotational kinetic energy of a sphere that rolls along a horizontal surface without slipping, and it has a speed of 6 meters per second. The sphere has 2 kilograms of mass and a radius of 5 centimeters. So originally, when we found kinetic energy, it would be 1/2 mv squared, but we're looking for just how much is rotating this, okay? There's energy used or energy in play here that is just rotating it. If something is spinning, it has energy. So we have 1/2 I omega squared, right? We just dealt with a solid sphere. You might have this memorized. The I value for a sphere is 2/5 mr squared. Good. And the other thing we know is that V, if we're talking about something rotating, is equal to R omega, or the rotational speed times the radius. So instead of it just being 1/2 I omega squared, we could say that it's 1/2. What are we going to plug in for I? What are we going to plug in for I? 2/5 mr squared. And what can we plug in for omega? If we want this, yeah, V over R. And then we're going to square that omega. That's omega squared. Cancel the squareds? Cancel the R's entirely. Yeah. This R goes away with this R. You've got R squared here, R squared there. Pretty much I'm distributed that squared and then canceled. Yeah, you're canceling out those 2's as well. And so we have 1/5, you're right on the 5, 1/5 mv squared. Is that all that's left? It's not 1/2 mv squared, it's 1/5 mv squared because we're dealing with what shape? A sphere. And this is just the energy used to spin that sphere.
So it takes less energy to spin a sphere than to push a box.
It takes less energy to spin a sphere than for it to slide across. There's still going to be some energy in its forward motion action, but this is just it spinning in space, floating. Yeah. That is a joule. Newton meter is a work unit, which is a joule unit. Yeah. Work is Newton meters. If you report it, if I'm looking for energy units and you said Newton meters, I would be happy. If you said torque units and you said Newton meters, I'd be happy. But if you said torque units and you said joules, I would be unhappy. Okay?
It should be in the same situation.
Yeah. Yeah, Newton meters is good for joules when we're talking about energy or work, but not so much. I haven't seen people refer to it in torque, and it sounds kind of sketch to me to do that.
How many points would we lose if we were right? Joule radian.
I don't know because it would depend on the problem. All right, we're at a good place to plug it in, right? 1/5. Screen kicked out again. 1/5 m, which is 2 in the problem. V. What's V? 6. One fifth 2 times 36. Should probably be 14.4. I would try it in the calculator, make sure you can get there. And in fact, I wouldn't just trust it outright. I'd type it in the calculator, but we did it last class period, so I kind of trust it right now.